Molecular Workbench has a large collection of activities. This video showcases one of them. In this Molecular Workbench activity, students can explore and discover molecular self-assembly using a sequence of computational models. Molecules can assemble themselves. Scientists are now learning how to engineer this process to make new products. This is an important research direction for nanotechnology. On the first page of this activity, students interact with the models to observe the emergent phenomena, and they'll investigate the factors that are important to self-assembly. Students can compare behaviors of different models under different conditions. Students can explore molecules with different shapes, and self-assembly only happens when the shapes match. Here we look at a three-dimensional structure of an insulin dimer. You can rotate the molecule and examine it from different angles. The students can run a dynamic model that simulates the formation of dimers and take a snapshot of the simulation. You can describe your snapshot, then use your snapshot to answer a question in the activity. Notice that all images you have taken are displayed as thumbnails in a scroll panel. Choose the one you think is the best to answer the question and drag it into the box. This simulation shows a self-assembly of a more complex structure in a cross-section view. Within a few seconds, the molecules that were originally randomly positioned self-assemble into a microtubule structure. You can look at the polarity of the molecules with color shading, which shows the reason that they form this particular pattern. This simulation shows the formation of a monolayer on a substrate, which models nanolithography, the technology of printing really tiny patterns. The following simulation gives students the opportunity to try to assemble the monolayers manually. They push the molecules to the substrate and demonstrate to students that it's really difficult to do. On this page, students are challenged to design their own structures using self-assembly. They can easily copy molecules of different shapes and drag them into the container. They can charge the molecular surfaces. When students run the model, they discover what pattern the molecules will form. They can try different shapes and charges and observe the results of self-assembly. At the end of the activity, there is a summary page that contains questions to test what students have learned. After they have answered the questions, students can create a report that automatically collects the answers to the embedded questions, including selected snapshot images, and formats them into a page that can be printed, saved, or submitted to the teacher.